Hi, welcome to Easy Math. My name is Zishan, and in additional math IGCSE, we're going to look at equations and inequalities with modulus of a linear function, with a modulus of a quadratic. By modulus, I mean absolute functions. So uh, let's look at a few examples here. Okay, now let's look at this one where we have absolute function of 3x minus 2 added with a 5, and we are supposed to sketch it. And then we have y equal to 11 minus x. And that of course is a straight line. Now, see, what I want you to understand here is uh, sketching them, being able to sketch them is a different aspect. What I want to do here is simply explain how to solve this inequality. So let's just go uh, sketch them out on Desmos and then uh, think about what to do with this particular inequality. So here, so we are supposed to do 5 plus. See, the best way to approach this sketch of 5 plus mod of 3x plus 2, 3x minus 2, is instead of going at the whole thing together, I say first go sketch this thing, and then there it is. This is what you should get if you are gonna sketch the mod of this linear function. This is what you're gonna get. After that, I would like you to shift this entire thing 5 units up. And that is what a 5 plus mod of 3x minus 2 would look like on a grid. The entire mod of 3x minus 2 shifted 5 units up. What does that mean? So if this is a 2 by 3 comma 0, you will see this vertex, this vertex at 5 plus 2 by 3, which is a 17 by 3 comma a 0. Oh, sorry, 0 comma 17 by 3. Oh, wait, this is a 2 by 3. So 5 plus that. Oh, no, wait. Yes. Nice. So the entire thing needs to shift up by 5. It means that the y coordinate is supposed to change. So there it is. So you go 2 by 3, which is literally 0.6667, comma 5. That's where you'll see the vertex of this thing if this is sketched first. Look at this one, a 02. A 02 will become a 07. 07. There. And that gives you a rough idea about what this may look like. So there it is. I'll introduce the whole thing, and there it is. There. 5 plus mod of 3x minus 2. Okay. So these are the critical points. Now we're going to go sketch 11 minus x out there. 11 minus x, there it is. 11 minus x. And then we are gonna see how to solve this inequality. Okay, now watch carefully. Okay, what we are looking at is 11 minus x less than 5 plus mod of 3x minus 2. How to solve this inequality graphically? Well, all you got to do is look at the points these intersect. There. Thing is, you may not be able to sketch them this exactly when you are given a grid. So a range of answers is acceptable, but you want to be close to what Desmos has there. So all I want you to look at is the values of the x coordinates these two curves are meeting. And for this 11 minus x to be lesser than 5 plus mod of 3x minus 2, you're only going to look at the values of x for which the black curve, the black straight line is below the red thing. Now, how? Wait, look at this value of x, a negative 2. Well, don't you realize if we go to the left of negative 2, taking up x values lesser than minus 2, for all of those x values, the black straight line is below the red thing. And that's what you want. You want the straight line 11 minus x to be below that. So what I'll do here, this is definitely one of the set of values for x. In a way, this is lesser than that. And look at this thing. The black curve for the values of x to the right of 2 are also have the black thing below the red thing. So I go x greater than 2. For all the values of x which are to the right of 2, I have 11 minus x lesser than 5 plus mod of 3x minus 2. And that is why my final answer should be x lesser than minus 2. Or the better way to write is negative 2 is greater than x is greater than 2. There. Done. That's it. So once you have sketched them, looking at the points of intersection should be good enough. And for if the black thing needs to be 11 minus x needs to be below that red thing, all you want is x to be to the left. In a way, these points is what you're trying to address, and this whole thing is below the red thing, and that's about it. Again, we're going to look at another set of linear absolute functions and figure out the answer for the inequality with them. So you have got a absolute x minus 5 and a 6 minus absolute 2x minus 7. And then there is, of course, the inequality. Remember, you're always given a grid. Not always, in these questions at least, you're given the grid. So it's easier for you to predict what the point would be for an inequality. I'll sketch these things again on Desmos and we'll see what to do. See, before we go actually solve the inequality, there is something very special happening about this inequality, this mod that you're supposed to sketch. You've got a mod of 2x minus 7 with a negative and 6 out there. So this is what you're looking at. The thing is, how to go about sketching it, you are supposed to go sketch this first. Okay, so there it is. This is what it will look like. Then, what would happen if there was a negative in front of it? Well, that is something you should notice. Look at the green thing, and the moment I introduce a negative sign in front of it, you watch what happens. Look at that. Without the negative sign and with the negative sign. There. So the entire green thing flips about the x-axis the moment you have a negative of mod of 2x minus 7 there. And then you're supposed to add a 6 to it. The whole thing shifts up by 6 unit. And this is what you will see. And there it is. The final thing. The vertex for negative of mod of 2x minus 7 was out here. And since you have added a 6 to it, the whole thing will go up by 6 units. And you will have this vertex at a 3.5, comma, a 6 now. And look at that. There, 3.5, comma, a 6. Not only that, you also have the y-intercept, which was a 0 comma minus 7 for this thing on the left. If you can see, add a 6 to it, you'll find it at 0 comma minus 1. And yes, look at that, a 0 comma minus 1. Now these 2 points, a 0 comma minus 1 and the vertex of 3.5 comma 6, should be good enough for you to get this arm, the left arm of this uh, linear mod. And of course, the right arm would be a reflection of it. So there it is, the sketch for 6 minus mod of 2x minus 7. And now you have our x minus 5 already asked in the question involving the two, involving the inequality. There are two absolute linears there. So there it is. There's the other one. Mod of x minus 5 and 6 minus mod of 2x minus 7. Now you want the x minus 5 to be lesser than or to be greater than 6 minus mod of 2x minus 7. To me, with the sketches already there, what it means is I'm looking for the values of x for which the red thing is above the black thing. Red above the black thing, because you want mod of x minus 5 greater than 6 minus mod of 2x minus 7. Okay, so first I look at the points of intersection. There it is, 2, 3, and 6, 1. And then I very clearly see if I go to the right of this point, meaning x lesser than 2, I have this red thing above the curve there, which is 6 minus mod of 2x minus 7. And if I go to the right of 6 with the x values there, x greater than 6, again the red thing is above the black thing and black curve, and that's about it. And that's what you want. So x lesser than 2 and greater than 6. 2 is greater than x greater than 6, and that's your answer for this inequality where they asked x minus 5 mod is supposed to be greater than 6 minus mod of 2x minus 7. Okay, so that was an example with inequalities and modulus of linear functions. Now we're going to look at inequalities without any mod on them and a graph given. So look at this one, fx lesser than equal to minus 1. Okay, so let's see that that's the curve for fx already drawn there. All you want to do to solve this inequality is draw a horizontal line at y equal to minus 1. Done. Okay, and then you are gonna look at the coordinates, especially the x ones. So for this one, it's supposed to be negative 1.1, 1.2, 1.3, 1.4, 1.5. So there it is, negative 1.45. This one is about negative, so this is 0.1, 0.2, 0.3, 0.4, negative 0.4. Okay, and this one is about 0.9, 0.8, 0.8. There. After you have located the x coordinates of these points, when asked to solve this inequality, I'm only gonna look for the values of x for which you have the curve below the line. Since there's a lesser than equal to sign here, I'm going to look for the values of x for which fx is below the line y equal to minus 1. This is line y equal to minus 1. Okay, so there it is. If I go to the left of this thing, I see that the curve is below. So this is the portion for which fx is below minus 1. Look at this one. If I go to the right of minus 4, minus zero point 0.4, and to the left of zero point 0.8, there it is. This is the region where fx is lesser than minus 1. So my answer to this inequality would be a very nice x lesser than negative 1.45 and x lying between zero point 0.8 and negative zero point 0.4. And since they want it to be equal to, I'll put it here also, equal to, since there was an equal to out there in the sign itself. So the point is for you to draw a y equal to minus 1 line and see where the curve is below the y equal. If it was fx greater than equal to minus 1, well, I would have chosen these regions. I'll draw them in a different color. Look at that. There, I would have chosen this region and this region where the function is above the value of minus 1. And that's about it. This is your solution for this question. Okay, so those were a few inequalities which involved modulus function and also in general inequalities without any mod in there. See, we saw a mod linear kind. We also saw a cubic kind. Now we're going to look at a mod with a quadratic in there, and there's a equation, not an inequality, it's an equation. What we're dealing with is this: we're supposed to find the set of values of k for which 5x square minus 14x minus 3 mod is equal to k has exactly 4 solutions. Well, questions like these are always going to be accompanied by a graph. There's always supposed to be a graph. So first, you want to sketch this, and then go about doing the part 3, where you're supposed to find the values of k. Okay, so let's see. I'm going to sketch that on Desmos and see. See, also the key to be able to sketch a modulus of a quadratic function, the thing is for you to sketch the quadratic as it is, and then you look at the region which is below the x-axis. There it is. That's the region below the x-axis. You are supposed to reflect it about the x-axis, and there, this would be the mod of the quadratic. There it is. So let's introduce the mod of quadratic into the grid there. So you go this, and there it is. As you can see, the vertex which was at a 1.4 and a negative 12.8 is at a 1.4 and a positive 12.8. The whole graph flips. The negative part of the graph flips towards the positive y. And it's known as the flip about the x-axis. Okay. Now let's come to the equation they have asked. You want the set of values of k for which this equal to k has exactly 4 solutions. Okay. See, before we get into this, I want to see how many solutions do we have for this equal to a 2. What do I do in that case? Well, I have the curve. I'll draw a line which is y equal to 2, and I'll simply read the coordinates of these points. The x coordinates of these points are the solution for this equation there. Okay. Let's see. So let's do a mod of 5x square minus 14x minus a 3 equal to 2. Before I get to the values of k and all in that question, I want to see how many solutions and what are the solutions for this thing first. Okay. So I go draw y equal to 2, and for this equation, x is supposed to be negative 0.32, a negative 0.07, 2.87, and 3.12. Four solutions I have for this one. Okay, let's change. Let's change it to 4 maybe. Okay, let's see. There it is. Now I'm looking for the solutions of this equal to 4. There it is. Y equal to 4 line. 1x, another x, another x, and another x. So four solutions for this thing. Now you should have noticed the pattern. If I go change it to a 7.7, if I change this number of that's number 4 to a 7.7, again you see you'll end up with four solutions. The point is, as long as these value is these values are below the value of 12.8 and above a 0, you will end up with four solutions to this thing. Go change it to um, 20 maybe. See, let's try and find out the equation number of solution for this thing. 15 equal to 15. So again, I draw y equal to 15 and see, oh, there are only 2 points of intersection. X is this much and X is that. Well, the reason is you literally went up the vertex. You're above the vertex now. Now this horizontal line y equal to 15 won't have 4 points of intersection. For so the final verdict here is for 14x minus 3 equal to k. For this to have four solutions, the k value should be between 0 and the y coordinate of this vertex, which was a 12.8. There, look at that, 12.8. And the moment I bring it down to 12.8, you'll see, look at that. Hey, there, three solutions instantly. And yeah, anything below 12.8 and above 0, you'll see the line intersects the curve four times. There are four solutions there are. Okay, so that's about it. Okay, so these were a few questions that I wanted to discuss. There are a lot of them in this particular book, and I will put up the link to this book for you to practice questions. You're supposed to look for them in the chapter 2, quadratic functions, and of course, you can go solve a few more of these to get a hang of them. And for now, that's it. I'll see you soon. Bye bye.